Good morning guys and welcome back. In this video we're gonna talk about regression and we're gonna do a small comparison between regression and correlation explained in the previous video. Now regression is also another data analysis tool in Excel that helps me understand the variance or the variation of a certain y in terms of certain independent variables x. What does this mean? If I have x1, x2, x3 and I know that y depends on these variables and I need to find the equation of this y in terms of x1, x2, x3, I need to use this regression. This regression will give me the coefficients of the equations of y in terms of my variables x1, x2, and x3. This means, guys, that y is a dependent variable that depends upon some independent variables like x1, x2, and x3. How to find this regression? I'm going to keep the same example that I have covered in the correlation type, but it's about the ice cream sales versus temperature. But here I'm going to find the equation of ice cream sales versus this temperature. I know that there is a correlation between them because what I did in the previous video is to confirm this correlation, and I have found that the coefficient of correlation is 0.97, which means 97% of these variables are correlated. So I'm going to find now this equation using regression on Excel. So basically, I have first to select data analysis and then select regression. And then I have to indicate my input y and my input x. And remember guys, y here is the ice cream sales, and I'm going to find the equation of this y in terms of 1x, which is here the temperature, and then I have to see the residuals. What is the most important parameter in these residuals in the regression type is r squared. R squared is basically the proportion of the variance of this dependent variable y that is predictable from the independent variable x. What does this mean? In this case, you're gonna see, guys, whenever we do the regression on Excel, that r squared is equal to 0.917. And what does this mean? This means that 91% of y, which is here the ice cream sales, could be predictable from x, which is the ambient temperature. What is the difference between this r squared and the coefficient of correlation? The coefficient of correlation will only give me if they are correlated or not. And I found in the previous video that yes, they are correlated and 96% of the variables are correlated. However, here r squared will give me if there is another x, another independent variable that y depends on. For example, guys, in this example, 91.7% of the variation of ice cream is well explained by the ambient temperature. But this also means that there is 8% of the variation in ice cream sales that are not explained by the temperature of the day, and they could be explained using another independent variable x2. Like for example, the age of client. I know that children prefer more ice cream than adults, which means, guys, I can have more than x. I can have x1 and x2, and if this y is well explained by x1 and x2, I'm gonna have r squared that is greater than 91.7 or that is closest to 1. And the closer r squared is to 1, the better the regression line fits my data. Let's now do this example on Excel. So I have the ice cream sales versus temperature, and I'm gonna now find the regression equation. So I'm gonna select data and then data analysis, and then I'm gonna select this regression. Now for the input range y, this is my y that I need to find its equation versus x. So I'm gonna select this and I'm gonna keep the title because this will facilitate my analysis later on whenever I see the results. And then I'm gonna select x, which is here the temperature. And then I'm gonna select labels, guys, because I kept the title of these columns. And then the output range could be any cell that you can select. So here I have selected F3. and then I'm gonna select residuals because I need to see these residuals. From these residuals, from R squared, I can predict if it is, if the variation of y are y predicted by x. So I'm gonna click on OK, and let's see the results. So here what matters for me, as I said, is R squared. 91.6% means that y is well explained by x, the variation of y is well explained by x, and this is very close to 1, so my results are okay. And then here I have another table here, and it's very important table. I have the coefficients here for intercept and for temperature. What does this mean? Intercept means, guys, that if I need to explain this regression using an equation y is equal to ax plus b, b will be this intercept, which is minus 159. And what is a? A is the slope, and it is the coefficient of x, since I only have here one x, and this coefficient is 30. This means, guys, that the ice cream sales is equal to 30 times the temperature in degrees Celsius minus 159.474. Now, guys, what is also important to know is that this p-value here must be less than 0.05. If this p-value is not less than 0.05, then this means, guys, that there is no dependence of my y on my x. So this means that there is no regression between y and x. Make sure, guys, that your p-value here is less than 0.05, like in this example, it is 1.02 times 10 to the power minus 6, which is very small, which is very less than 0.05. Now what I'm gonna do is to take another x where the p-value is greater than 0.05, or where there is no correlation, no regression between ice cream sales and this variable here. So I'm gonna select, for example, the age of the buyer, right? So I know logically that ice cream sales will not depend on the age of buyer. It will depend basically on the age of the client. So I'm gonna use the age of buyer here to see if p-value will be greater than 0.05, all right? So I'm gonna use any random values for the age of the buyer. So here, guys, I have selected some values, some random values for the age of buyer, and I'm sure that there will be no correlation or regression between ice cream sales and the age of the buyer. Let's do it again using regression. So I'm gonna change, of course, y range because it is now C1 till C13, and x is now from A1 till B13. And then I'm gonna keep all others the same. And then yes, I'm gonna overwrite the existing data. So guys, as you can see here, the p-value of the age of buyer is 0.729, which means there is no correlation, or the regression is very weak. Which means, guys, I cannot explain the ice cream sales by depending it on the age of buyer. There is no dependence here. So I have to remove this age of buyer. P is greater than 0.05, which means I'm gonna remove this age of buyer. While the temperature has a very small p-value, 3.89 times 10 to the power minus 6, so I'm gonna keep the temperature and remove this age of buyer. So let's delete it and instead put the age of client. So guys, here I have added the age of client, and I'm sure that the ice cream sales will depend on this age. Alright, so let's see. Now, y is the same, x is the same, because in fact I have replaced the age of the buyer by the age of the client, and then I'm gonna keep all other options the same, click on OK, and overwrite my existing data. So let's see what happens here. So here, guys, you can see that the age of client has a p-value of 0.037, which means, guys, it is less than 0.05, so it is acceptable. And this means that the variation of ice cream sales is also explained by age of client together with the temperature. So what will be the equation basically, guys? The equation will be that y is equal to the coefficient of the temperature, which is 16.34 times T minus 26.44 or 44, yes, times the age of client plus this intercept here, which is 358. So guys, this will be the equation of y. Now here I have two variables. One is t and the second one is age. And of course, I have the negative sign for the coefficient of age because when the age of client decreases, the ice cream sales will increase. So guys, if you want to make sure that this ice cream or these ice cream sales are well explained by the temperature and the age of client using this equation, we can, guys, basically do it here. So we can verify this. For example, I can use this equation. So it is equal to 16.34 times the temperature minus 26.44 times this age of client plus 358. And then, guys, I'm gonna drag this for all the cells. And you can see, guys, that these values are very close to the ice cream sales. So this equation explains well the variation of ice cream sales in terms of these two independent variables, temperature and age of client. Thank you.